Hello Internet, my name is Quinn and this is Blondihacks. I'm working on the Pennsylvania A3 switcher this week. We're going to build the coal bunker. I'm not sure why they call it that, but what it is, it's like a bunker shaped object that holds coal. It's a pretty complex structure, lots of interesting stuff, so let's go. Here's where I left off last time. The tender tank sides are in place. Now I'm going to make the coal bunker that sits in here in the middle of the water tank. It's like a C-shaped cutout in the water tank, and it holds the coal in a convenient way for the shoveling. It's a complex frame structure consisting of a lower and an upper frame and a bunch of trim pieces. I'm going to start with the lower frame. I rough cut that to length, and then I'm going to clean up the ends on the mill. This piece is short enough that I can do it all in essentially one setup in the milling machine. I have enough table travel to work on the whole piece in one setup. So I start by facing the ends, machining it down to length, and then I can use the edge finder to find the ends and center up on the piece, and then do all of the features relative to the center line of the piece. For me, that's the most accurate and quickest way to do it if the piece is small enough to fit within the table travel of the mill. The features on this piece are some relief cuts that are used to control where the bends go. This is a U-shaped piece that has two bends in it, and these relief cuts are where the bends will go. Kozo has figured out, I guess, how thick the material should be here in order to bend it and have it land at a nice radius. I'm making sure that my grooves are the right width, and I go down and make the other one. We get to see a neat effect with this piece. Brass bar stock is cold rolled. Just like there's hot and cold rolled steel, the hot rolling process runs the material through the rolling mill hot, and that leaves that mill scale on it that you see on like structural steel. So you can also buy cold rolled steel, or brass bar stock like this is cold rolled. And what they do is they run it through the mill again, cold, and that removes the mill scale and leaves a nice finish to bring it down to final dimension for the bar stock. However, that process puts a lot of internal stresses into the material. And when you machine away half of it in a couple of sections like this, you release the stresses in half of that material, and it'll come out banana shaped like this. Technically, this always happens when you machine cold rolled material, but it's not really a noticeable issue unless the piece is really long and thin like this one is. In this case, we actually want it to bend in those areas, so this isn't a problem. It's just neat to see the effect. To bend this into shape now, I'm going to anneal it, and I'm going to bend it over a mandrel. I've got a little mini hearth set up on my bench near my vise, so I've got the mandrel clamped in a handy place, and I'm going to anneal the relief sections where I want the bends to happen. I'm not annealing the straight areas because that way they will tend to stay straight while I do this. I bent that around my mandrel, and somewhere around here is where I remembered that radius and diameter are not the same thing. I had chosen a mandrel that was the diameter of the number in the drawing, not the radius. So I went back to my scrap bin, found a piece that was the correct diameter, twice the radius as shown in the drawing, and I hammer formed my curve into the correct radius. Make sure I'm landing square on that bend, and that is looking pretty good. I bent the other leg of the U-shaped frame the same way, again making sure everything's staying square, and the U-shape itself ended up square on the bottom, so that certainly means I did something right. I'm pretty pleased with that. To make sure it lands in the correct place on the floor of the tender, I've got a gauge pin in one of the bolt holes, and I'm accounting for the thickness of the material and the radius of the pin, and calculating where the rear edge of the lower frame should land. And I'm scribing that on the base plate. That will help me align this thing correctly while I check all of the dimensions and make sure that everything's going to line up properly. I then spent a non-trivial amount of time making sure that this frame is absolutely exactly in the correct position, that everything is square and everything is aligned as best I possibly can according to the drawing. This is going to be my reference for building up the rest of the coal bunker, so I really want this to be accurate because any errors here are going to make life much more difficult the further up on the coal bunker I go. Once I was really happy with the position of that, then I can go ahead and transfer punch the bolt holes into it. Now I will say that my bolt holes don't quite exactly line up. So they still line up close enough, the bolt holes are still in the material, so I went ahead and punched them, and I'm going to drill and tap them there. They just won't be centered in the material the way they're supposed to be, so there's some little error here somewhere. I'm not sure exactly where the error is, if it's in the base plate or if it's in this frame piece. I'm not sure, but by transfer punching and drilling and tapping where they need to go, I think it'll still work out. Because as I say, all of the dimensions on this frame piece seem to be correct, so the bolt holes still land in the material, so I'm going to roll with it. A few creative setups and a lot of drilling and tapping later, and I've got all of the mounting holes for the coal bunker drilled and tapped into the lower frame. This is great news because what it means is I can now screw this thing down to the base plate and it'll stay there forever, or at least until I get the coal bunker finished. And that's going to be a rock solid reference for everything that comes after this. This is going to be my source of truth for the rest of the coal bunker. Everything has to fit this or it's wrong. The upper frame piece now is quite a bit trickier. It's much, much longer. So this is going to be a longer piece that I'm going to have to work with, because this is a U-shaped bend like the lower one, but it also has vertical legs that bend downwards at the front. Now this piece is too long to fit in my mill in a single setup. I can't do all the features because I don't have enough table travel to get all the way to the ends, to machine the ends and then mark a center line and do all the features in one setup like I would usually like to do. Instead, I'm going to have to work on this in sections. So I'm going to mark a center line on this. I'm leaving the ends unmachined and the piece is over length. What that means is I can work from the center out and I can push any error out past the ends of the piece as I go. However, because I'm working on it in sections, that does mean my reference is going to change as I do each feature. And anytime you change your reference, you're introducing error. If you're very, very careful about it, you can keep that error to under 1,000th for each reference change, but that error is going to accumulate. So on a piece like this, I might end up with 3 or 4 or 5 thousandths of error by the time I'm done on some of these features. However, for this piece, that's just fine. That's well within any tolerance that this piece has. The first two features are relief cuts for bends, just like on the lower frame, and those were done relative to that center line that I scribed. Now I reset the piece upside down, and I line up on my center line again, and I make a really long relief cut down most of the piece. This is going to hold a trim piece called the verge board that sits at the top of the coal bunker. This is a shallow relief just to recess some sheet metal flush with the outer surface of this frame. Now I only have enough travel to do half of it in one setup in my vise, so then I edge find on the edge that I just cut, and I cut the other half in a second setup. So again, each time I change that reference point and I do another edge find or another center alignment, I am introducing a little bit of error, but it shouldn't accumulate too badly over the life of this part. Those are all the features in the middle section of the piece. As you can see, this thing is quite long. Now I have 2 more relief cuts to make at the ends, so I'm going to be working in yet another section, so yet another reference. But these relief cuts are tricky because these bends are 90 degrees rotated from the upper bends, so I really got to make sure I do this right. This hurt my brain a little bit. Not only are they 90 degrees off, but the relief cut is on the insides of these bends, not the outsides. Now my reference for these outer features is the relief cut that we did for the sheet metal. So to catch that edge, I put a parallel in there and edge find on that, and then I can go ahead and make my relief cuts from that measurement. Again, that's a new reference, so introducing a little bit of error, but if you're careful, you can get away with this to a point. From there now, without moving the piece in the vise, I can move down and machine this end of the part to final length. This does not introduce error because I'm using the same reference as that last edge find we did because the part hasn't moved in the vise, and the DRO and everything has the same reference. So I can tap my parallels out of the way and then machine this end of the part down to length such that the length of this section at the end of the piece is correct according to the drawing. Once I do that at both ends, then the overall piece will end up the correct length. Here's that final piece. You can see pretty tricky at the end of the day to get all these little relief cuts the right depth and on the right side and in the correct places. We won't know for a little while yet if I did all this correct, but this was certainly a brain bender, this one. It looks like a straightforward part in the drawing, but once you actually sit down to make all these cuts, you gotta do some thinking. For the first of the bends in the upper frame, these bends are actually parallel to the lower frame bends that we just did. However, because of that relief cut for the sheet metal, the radius of the upper bends is actually slightly larger because of those relief cuts. So I need to turn a new mandrel for these bends. I had to flip my mandrel around that I used to get a thicker end, and I'm turning this down to the diameter of the other end plus the thickness of the sheet metal that's going to be in that recess. Then once again those relief cuts get annealed so that they will bend and hopefully nothing else will. And away we go. This is pretty easy to do, I have to say. Once you anneal it, it's so soft that you can bend it right around that mandrel by hand, and for the most part, you get a nice, accurate bend this way. Sometimes you have to hammer form it a little bit on the mandrel to tune up the radius, but this often just works the first time, I find. The other two bends, however, are trickier because the relief cut is on the inside of those bends, so I can't use a mandrel the same diameter because it won't fit inside that relief cut. So I have a much smaller mandrel that's just going to help the material bend in the right place. I've got the mandrel centered on where I want the center of the curve to be, and that'll just kind of get it started in life going the way that I want. And then the relief cut itself and the annealing is going to basically make sure that it overall bends in the place that it's supposed to. As long as I get it square in the end, this should be basically correct. At least that's the hope. We don't need absolute accuracy on these bends either. As long as the two sides match, we can fit all the other pieces to it. At the end of the day, these curves are aesthetic. Rather conveniently, the interior dimension between the two frame rails ends up being exactly 2 inches, so I can use my 1, 2, 3 block to prop that up. And make sure that everything is aligning well and everything is going to be square when everything's assembled. And I gotta say, that's looking really good. I did a little bit of tweaking here and there. There was a bit of a twist in one of the frame rails and a little bit of adjustment here and there, but overall, that went very well, I think. So now I can move on to the verge board. This is a trim piece that goes around the top of the coal bunker. It essentially acts as a funnel, helps direct coal into the bunker because the bunker is typically being filled from a chute or a tipple of some sort from above, and coal was expensive, so it helps to make sure it all goes in the right place. This is a complex sheet metal part, so I'm going to make a template for this one. There's a lot of curves and a lot of angles that all have to be just right for this thing to work out. I don't want to take any chances doing this in sheet metal, so to the cardstock and the drafting tools. The book does supply what's called a developed drawing for this part, which is to say an unfolded sheet metal diagram that has all of the dimensions of the piece before everything is bent. That is immensely helpful, saves you a lot of grief. So I was able to create the developed sheet metal piece in cardstock and then fold it up and make sure that it's all going to land in the correct place. Survey says, it's helpful that this cardstock that I have happens to be very close in thickness to the final sheet metal. That makes a big difference in making sure that your template is accurate. And that, I have to say, looks pretty good. I think that is going to be a good fit. So I felt good about that, so time to transfer that to sheet metal. The corners might need a little massaging in the final sheet metal. They don't seal tightly down on the frame rail as much as I would like, but we'll see how that shakes out. I'm going to trace this template onto my brass now. I'm using die-cam for this. People often ask, why do I sometimes use Sharpie and sometimes use die-cam? The difference is basically that Sharpie is quicker and easier, but a lot less durable. Sharpie is removed by cutting oils, for example, and, well, looking at it funny. Die-cam is extremely durable and will stay in place through multiple operations. So if I'm going to be doing a lot of cutting, a lot of machining, a lot of filing on a part, die-cam is the way to go. Unfortunately, this die-cam is a little bit old, so it wasn't covering very well, so I had to put a lot of it on, and when you put die-cam on too thick, it doesn't scribe very well. It tends to chip instead. So you'll see a lot of chipping in this piece, which means that my scribe lines are not very accurate. However, they are good enough for rough cutting, which is all I'm going to be using these lines for. I can now rough cut this out on the bandsaw. The template will be the final arbiter of the dimensions on this part. The scribe lines are just there to get me in the ballpark and save me some checking against the template. Next, it's over to the die filer to bring those rough saw cuts down close to my lines. I'm using a couple of different files on the die filer, mostly the triangular file, which is great for getting into inside corners, and I've got some action with a half-round file as well for the curves. As I work, I'm checking against my paper template to see how I'm doing. If my scribe lines had been more accurate, then I may have just been able to trust those, and this might have been a little easier, but working to the template is not too bad. Well, there's my final piece. The first bends to make are the tabs along the bottom. They get bent to a 15-degree angle to give the verge board the outer kind of funnel shape that it's supposed to have. I did this with these sheet metal seaming pliers. These are ductwork tools that you can get at any big box store. They are great for doing this kind of small-scale sheet metal work. I'm checking on a protractor to get those angles correct on those tabs. Looks like I overdid them a little bit, so I'm kind of unwinding them a little bit. The piece is not annealed at this point. I'm just bending these cold, which is not too difficult. Now I'm going to do the curved sections, and these I am going to anneal for because these need to be nice, graceful curves, and annealing really helps with that. So once again, annealing just the relieved areas in the center where the bends are supposed to go, and doing my best not to anneal the straight sections on either side, which really helps keep those sections straight and give you nice, clean, curved tangents. Let that cool off naturally once again. I don't want to quench it because that has a chance of warping it. And then over to the mandrel and an easy bend around the mandrel to get those curves in there. Again, once the stuff is annealed, it bends so easily that you can just do it with your thumbs. It's great. And there was some fiddling to get it to fit perfectly, but after a little back and forth with tweaking the tabs and tweaking the radii and so on, I did manage to get it to fit into that relief cut around the upper frame where it's supposed to go. This verge board is what that long, shallow relief cut on the back of the frame piece was for. If you remember when we milled out that relief, that's what it was for. This next piece is really tricky. This is a little trim piece. It's like a stiffener rib that goes all the way around the upper edge of the verge board. So it's a very complex shape. I'm going to start by tracing my template to get the outer shape, and then I scribed an offset for the thickness of the trim piece all the way around the same shape. So that is the piece we need to cut. Once again, I rough cut that on the bandsaw, and now I'm going to file it down to my lines. For the long straight sections, I'm hand filing, because for long straight sections, I find hand filing easier to get a good result than on the die filer. The die filer is better for smaller, intricate work and more curved things and funny shapes and so on. But when you want something long and straight, the die filer is a little trickier. The die filer is great on the inside surfaces though, where there isn't room for the file. So on the inside straights, I'm using the die filer and just bringing it down to correct width all the way around. You can see I'm deviating from the original scribe lines a bit, but that doesn't actually matter. As long as the piece is the correct shape and the correct width all the way around, then it'll fit. It doesn't matter so much exactly where the scribe lines are relative to my edges. So I did the straight sections and then blended the curves in between all the way around, one curved section at a time. All the while test fitting on the verge board to make sure that my outer surface is a good match for the edge of that sheet metal. Here's that final piece. This piece was a lot of work because it was all done by hand. There was really no good way to do any machine work on this, just a lot of hand work and a lot of test fitting. But moment of truth, let's see if it'll fit on the verge board. So once again, I've annealed the areas that need to bend, and I'm going to clamp one end, and here goes. I'm just going to use the verge board as the form because it's annealed, so it's easy to bend and doesn't have a lot of resistance. And around the corner we go, keeping it aligned with the top edge as I go. I did the second corner, and everything seemed to be going well until I got around to the other end, and yeah, sad trombone. I thought that my template would be close enough in size that I could use it for the length as well, but as you can see, it came up short. The thickness of the material and the fact that it's wrapping around the outside surface of the verge board was enough for it to come up short because I used the same template. Rather than make that piece again, which was a ton of work, I instead split it at the back where it's going to be easy to leave a little gap that's easy to fill with an extra little piece that I can solder in there. The book does not supply the developed drawing for this trim piece, and that's why I'm winging it here and thus failing. But luckily this little gap will be easy to cut and file a piece to fill. So more on that in a second. But first I need to get fixturing screws in this trim piece so that it will stay in place. So some very creative fixturing once again, lots of clamps to make sure everything stays in place while I do this. And I drill and tap some very tiny number 0 fixturing screws all the way around this trim piece. This will hold it in place until everything is soldered in place, and then all the way at the very end of the coal bunker we will file off all the screw heads and you won't know any of them were ever there. This is very tedious, intricate work. These little fixturing screws take a lot of time, but they are really worth it because they essentially guarantee nothing moves while you solder, which is a big deal on these model parts. Then as I add these screws one by one, I can remove the clamps. Careful. Perfect. There's one half of that trim band installed. I did the same thing for the other piece, and with both of those pieces screwed in place in their final positions, now I can cut and file this little filler piece to fix my little boo-boo. that also gets its own tiny fixturing screw to hold it in place for soldering. And that doesn't have to be perfect because everything's going to get filed to finish at the end, but I'm really happy with where this is at. There's some little discontinuities here with the top edges of the two pieces and so on, but again, all that's going to get cleaned up with filing at the end. But we are ready for some soldering. Everything gets disassembled and run through the pickle bath, including all the little screws, and then everything gets fluxed and screwed together. And the little screws get fluxed as well to make sure solder gets into the threads. We're using silver solder for this trim piece because the rest of the coal bunker is going to be soft soldered. So by silver soldering this piece, we ensure it's not going to go anywhere when we silver solder the rest of the assembly. But these are such small pieces that silver soldering is very easy. It doesn't take much heat when the pieces have this little mass. Plus, of course, this is a decorative piece, so none of these joints are all that critical, which takes all the stress out of it. This is nothing like boiler work. Silver soldering these little decorative pieces is easy peasy lemon squeezy with consent. Then cool off through the pickle bath and a little bit of cleanup later, and here is the current status. So that joint looks really good. I'm happy with that, and I can move on. It doesn't have to be, again, airtight because this is just a decorative piece. Things did shift and move a little bit under silver soldering, so it got a little bit springy. So I'm clamping it in place for the rest of these operations, and it'll settle into place over time. Checking my measurements against the drawing to make sure everything is landing where it should, and everything looks good. Things seem to be matching what the drawing says they're supposed to be, so happy with that. Now for the sheet metal piece that fills in all the rest. I'm using a pattern maker's tape to get the curved surface length. Again, there's no developed drawing for this piece in the book, so I'm measuring this and I'm going to make it oversized and I'll trim it to length later. Fabric tape is great for that kind of measurement. So I will mark out and rough cut a piece for this once again. I'm not bothering to machine any edges on this part because it doesn't matter at this stage. Everything's going to get filed down to final position anyway. I am, however, going to mark a center line, and I'm going to mark my bend lines relative to that center line. Now, I got a piece of steel here because Kozo has a suggestion for doing this bend. You machine up a couple of bars that have a shared straight machined edge that acts as a clamping edge for the tangent position of the curve. You put some holes in it so that you can bolt it on either side of the sheet metal. The idea is that this holds the sheet metal straight immediately on either side of the bend, which ensures a clean, nice looking straight bend. At least that's the principle. I already have my sheet metal clamping system that I use for milling, so I use that as my lower clamping bars. And the idea is that you're supposed to just be able to bend it now between these two sets of bars, and the curve will land where it's supposed to and be a nice radius. I have also annealed it to make this easier. And well, here goes. I've never tried this technique before, so let's see how it works. And the answer is, well, it worked okay. The problem is that the material tends to kink at the lower clamping bars, which is kind of what I would expect to happen, frankly. I don't know how it is that the curve is supposed to evenly distribute itself between those bars. I don't know. That seems to be what works for Kozo in the book, but I could not get that method to work. So I had to get out the mandrel once again and hammer form that curve to tune it up. Doing that, I was able to get a curve that I liked. It was a nice fit in that lower frame. However, somehow this curve has ended up in the wrong place. You can see I've got a lot of material sticking out one side, and I did the measurements, and when it wraps around, there won't be enough material around the other side. So rather than try to fix that piece, I went ahead and laid out a second one. You can move a curve with hammer forming to a degree, but if you have to move the curve a lot, it's very difficult to not mangle the piece in the process. I'm trying the Kozo method again just to give it another shot. He does not say to anneal the piece, so I thought, well, maybe that's the difference. So I did this unannealed, which as you can see was quite a bit more difficult. And well, that was actually just a lot worse. The kink was quite a bit worse. There's another reason this was so difficult that you'll see in a moment, but bear with me. So that was no bueno. Went ahead and annealed that, and once again I'm going to hammer form it to try and correct this curve. However, even annealed, I found hammer forming this material quite difficult. I wasn't quite sure what was going on here. And then I thought, this piece is kind of heavy. And then I checked the thickness, and yeah, I grabbed the wrong material off the rack. I grabbed something that was twice as thick as this piece is supposed to be. So I got to make this piece a third time. Luckily, I'm getting very good now in making this piece. So piece number 3 I then went ahead and did the, Quindunky method, which is to put something flat on either side of the bend and use a mandrel, and the piece is annealed. The little pieces of wood there help keep the sides straight on either side of the bend. If you just use your hand, it's easy to get a bend in there that you don't want. So using the flat pieces helps. And that curve is excellent. I've got a little bit of a warp on the flat section. That's not from the bending. That was from slightly overheating it while I was annealing. It warped a little bit, but I can hammer that out on the anvil. And that worked much better. So no disrespect to the method that's in the book. I'm sure it works for some folks, but for me it didn't. So the mandrel is my friend. I was still struggling to get a good fit though, and I finally figured out why. The dimension given in the book is for the outer surface of the material. However, the mandrel that you're going to hammer form around has to be the radius of the inner surface of the material. I had to put that mandrel over in the lathe, turn down the thickness of the material, and then hammer form it around this very slightly tighter radius, because now the outer surface of the material will be the radius specified in the drawing. And that was the ticket. Now I've got a nice fit, and it looks like I will now have finally enough material to make the other bend, and indeed I did. So that went pretty well. I did have to do a fair amount of going back and forth to the mandrel and test fitting to get both of these curves to be a decent fit and kind of land in the right place. And full disclosure, they are still not perfect. The fit around the top is better around the bottom, and I'm fine with that because the top is what's visible in the end. The bottom is going to be forever inside the water tank, so I don't care too much that there's gaps down there. And frankly, I'd kind of had my fill of working on this part, so I was happy enough with this fit. At this point, with everything clamped in place where it needs to be, I scribed the outline of the frame onto the sheet metal for later filing to fit. I removed most of the material on the belt sander, but I'm not going all the way down to that scribe line yet. Final filing to fit will be done after everything is fully assembled for the final time. Then of course the obligatory tiny fixturing screws. In this case, 14 of them all the way around this frame. This is very time consuming, this step, but it is important. You don't want to skimp on it. I spent several hours putting in these tiny fixturing screws on this frame, because you can see the elaborate, tricky setups that are required to ensure that the screws go in while the pieces are in their correct final positions. But if you do it right, the result looks something like this, or at least if you do it adequately, let's say, the result looks something like this. All those tiny fixturing screws are in place, everything looks correct, and we are ready for solder. Very exciting. So this whole structure now gets soldered together all at once using soft solder. Once again, this structure only needs to hold water around the back. It is not exposed to any heat or any pressure, so it doesn't have to be silver solder. I use the same basic process though. Everything gets pickled because pickling is just an easy way to get the surfaces clean for plumbing solder, and all the screws and everything all get fluxed as well. Everything gets screwed together and then solder is put in place. I ran out of my small diameter soft solder, so I'm using this big thick stuff. I hammered it flat to make it sit in there a little better. And away we go with the heat. I tend to overheat my soft solder joints. You'll notice the flux gets all black and starts to scorch, and that's because I'm just not used to how little heat soft solder requires. I've done so much silver soldering in my shop that I always end up cooking the flux and making a nasty smell in the shop from using too much heat, but I still get it done. I just got to recalibrate my brain when I'm soft soldering. A little bit of pickling and cleanup with a Scotch-Brite wheel on the Dremel later, and here's the structure so far. Almost done now, looking pretty good. Next step is to file off all the screw heads, which goes pretty quickly because they're tiny and they're brass. So a coarse file, a few strokes takes off most of it, and then a fine file to smooth out the surfaces. Those screws really do disappear after this. It's quite a nice technique. Then finally I file the edges of the sheet metal down to the outer surface of the frame so that everything lines up nicely, takes care of any imperfections that there might have been. At this point I can also now do any filing needed to blend my little repair area at the back of this trim piece. You can see some evidence of the repair there if you look closely, but I think once that's painted you won't be able to see any of that. The surfaces are all continuous by feel, so I think the end result should be reasonably invisible. At least I'm pretty happy with that. In my zeal to make everything watertight back here with the soft solder, I did manage to fill 2 of the screw holes with solder. That was easily rectified with a pin vise and the tap drill size, and then cleaning up the threads with a tap. Next, I put some light on the situation to check for potential water leaks. I want to make sure that there's no light showing through any of the joints. I did find some suspect areas, and then of course there's these big gaps here where the radius isn't correct at the back of the frame. I'm not sure how important these gaps are because I don't know where the top surface of the tank is going to land exactly. So these areas may not need to be watertight, but just in case, I am going to fill those with some little filler pieces that I cut and bend, and did another pass of soldering to seal all of that up. It may look like there's still gaps, but that's just at the top edge. It's all sealed there underneath. And it doesn't matter what it looks like back here once again, because this nice front surface is all that you will ever see. I put a lot more effort into making the front and the inside of the bunker look nice, because that's what's going to be visible. Let's get this in position in the tender. I'm not going to bolt everything down yet because there's lots more work to do, but you can get a sense of what this is going to look like at least. There it is, one coal bunker in the tender. You won't see anything below the bottom edge of the verge board, so don't worry about any ugliness that you see there. That's all going to be inside the water tank forever and ever when we're done. I'm pretty pleased with the progress so far. I hope you are too, and I hope you've enjoyed watching this process. Thanks for watching, and thanks especially to my patrons, my personal heroes who make all of this happen every single week. You all are the best. Couldn't do this without you, and I will see you next time.